In this video, we'll be looking at specifically the comparison test. Now, the comparison test, I would argue, is probably one of the more difficult tests to use on series, specifically because of the way that they are built and the way that they're set up. You have to do some heavy conceptual understanding to be able to manipulate these things. Now, what's really important with the comparison and the following test, limit comparison tests, is that they require you bring something to the table, something that you know is convergent. So we're going to go ahead and start the comparison test with the concept of we have a series, a summation a sub k, and we have a second series, a summation of b sub k. And these are both series with specifically positive terms. Now, again, it's important that we have these details identified, because if we don't, things can kind of go downhill from there. Now, we have two possible conclusions. Our first conclusion is that if 0 is less than all the terms of a sub k, which is less than or equal to all the terms of b sub k. So this is important to understand that if I have a sub 1, it has to be less than or equal to b sub 1. And this is true for every single individual term. And the fact that the summation of b sub k, so all the terms adding up, converges. Then it should logically make sense. Again, this should just logically make sense that if this term, for every single term, is larger than a sub k, and the series of b sub k does end up converging, the terms that are smaller than it, if they all add up, then a sub k should also converge. So the idea here for this particular detail is the fact that if I'm given some concept of a sub k, if I'm given this thing, then I have to bring b sub k to the table, and I have to be able to conclude that that summation of b sub k converges, and I have to show that b sub k is always going to be larger term by term case that of a sub k. So then I have to be able to then conclude that, well, obviously this then, the sum of all those terms should also converge. The secondary statement of the comparison test is that if instead I have 0 is less than b sub k is less than or equal to a sub k, and again, the idea is we're still given a sub k, and we're still bringing b sub k to the table, and I can also then conclude that b sub k diverges this time. Again, term by term, b sub k is smaller than a sub k, but all of the terms of b sub k added up become something uncontrollably large, or simply bounce back and forth forever. Then a sub k can't converge to anything because its terms are larger than b sub k, and it's simply diverging as well. So then we can then conclude the summation of a sub k also diverges. So let's jump straight into a single example of this, at least in this video here, and let's prove the summation of k equals 1 to infinity of 1 over k squared plus 10 converges. So I've given you the conclusion at this point that we know that this particular series k squared plus 10 converges, and I need to then conclude that it does, and I need to show how it does. So it's important for us to then come with a number of details. Well, it's important also to note that this series looks quite similar to that of a p-series. If you're looking closely, that it's got k squared in that denominator, and so I might think about 1 over k squared as a thing to view it close to. With that understanding, now keep in mind that this isn't a p-series. If it was a p-series, it would just be 1 over k squared, but it's not a p-series. However, it's close to 1, close enough for me to say, well, maybe I can compare it to that. And this is where the concept of the comparison tests come into play, is the fact that this is close to a p-series. How does this list of terms differ than or compare to this list of terms? Well, let's go ahead and write these two things down, and let's talk about how they compare. Well, if I take a number and I divide it by a number plus 10, whereas over here I'm just dividing it by a number. So let's just say I'm taking 1 over 1 versus 1 over 11. The idea is which one is going to be smaller. So 1 over 1 compared to 1 over 11, well, this one is obviously going to be larger, yes? So if that's the case, then this should be true for every single term. Again, 1 over 4 versus 1 over 14, and so on and so forth. This value is always going to be smaller than this one. Now, with that statement identified, again, this is the conceptual understanding that we have to bring to the table. I'm bringing this sequence to the table such that I can talk about the summation of 1 over k squared is a p-series with p specifically, again, it was greater than 1 such that it's convergent. Therefore, that series 1 over k squared is convergent by the comparison test. And again, this is what we have to write. We have to say, I'm bringing this series to the table. This series is a p-series. This series is convergent. By the comparison test, I've already made this statement true. Then the new series, I shouldn't say new series, I should say the series we were originally given, this series, is also convergent. Again, it doesn't seem like there's all that much math going on here, and there really isn't. And it's simply because we are just making a comparison of something we have to bring to the table. We were given this, it looks close to this. How can I compare these two things mathematically? Can I make an end result conclusion of how this thing compares to this thing? And if I can do that, then the comparison test is our friend. It will simply allow us to say, hey, this thing converges based on p series, this series converges, and therefore by the comparison test, because this thing is larger than this thing for every single term, then this thing must also then be convergent. Again, if this inequality was swapped, if this was a greater than symbol instead, this wouldn't work, okay? With this thing being less than this one, it wouldn't conclude convergency because this one was below it, converging for every single term we add to it, but this one was above it. There's no guarantee that the terms above are going to add up to something that is also convergent. This one's stuck bounded. It's bounding this one below it. This one then also has to converge. If the inequality is swapped, it doesn't have that bounding quality.